Yeah, we can see you, Sim.
Alrighty. Cool. So welcome. Let's see what time it is. A couple minutes after. Let's jump in. I am going to mute everyone's line, but if you have something to say at any point, definitely unmute yourself and chime in. All right. So this is our session 1 study group, and I've got a bit of an agenda over on this doc on the left. Hopefully everyone is also in the Slack channel, because I'm going to throw a couple of polls into the Fast.ai group that I'd love to get folks to respond to. So if you're not there, take a second to jump over there and respond to these polls. Basically, you do that by using the reaction, which is the little smiley thing, and just find the reaction that is, that matches these choices. The first is, where are you running the lessons? I'm just curious where folks ended up doing things. And the second is, how are things going so far? Let me get this chat window open. And so the way to respond to these, so it's easy to keep track, is if you hover over the item, just like if you like it, there's this little smiley face thing that says add reaction, and then you get this little, you basically smile with, you get these little emojis, and you search for the one. So the first one, you just put the number in and it'll come up. And then the second one, I think it's, actually you can see the little things you're looking for in this doc here. It's grin, expressionless, or sob, or the way we're voting. So while we're doing that, where I wanted to start with, just have folks kind of chime in on, what you found interesting, what stumbling blocks you ran into. We can just kind of open the floor up. Who wants to go first? Just unmute yourself and chime in. Not all at once, though.
I'll go here for a second if my kids can keep quiet. I thought it was really interesting, the data preparation steps. I hadn't really thought about it from an images perspective. I do data preparation all the time with text and whatnot, but having to take, say, 1,000 images and delete the ones that are below a certain size or that have certain file names or things like that, just to make sure that I'm feeding good data to the model in the first place.
Awesome. Yeah, great comment. I don't know if I'll mention it in case anyone missed it, but 313V on the Slack I posted a link to this Slack message. This person posted a bunch of utilities that, one of them was like a command line Python thing that will allow you to search Google images and collect images. The other was a Chrome add-in. Those look really cool. It never occurred to me to look for utilities or shortcuts for that part of the process, and I haven't tried these, but I can imagine, just based on the small amount of data that I collected for the homework, how much this would save time. Did anyone play with these, or is
Yes.
313V on the line?
I tried the Python Google image download tool, and it worked really great. I even created a just use keywords image classifier. So you just give the keywords and it's automatically downloading the images and creating the classifier. So you don't have to look at the images. I mean, it's just for fun, but.
How did that work out?
Really good. It worked really well. I'll post a link for this notebook. I just pushed that to GitHub. Wait a second. So I just posted the link on Slack.
Cool. Thanks, Kai. A couple of questions are in. Difference between Paperspace Core and Gradient. Core is basically a virtual machine with which you can get with a GPU. Gradient is a Jupyter notebook. So they deal with the virtual machine on the back end and you don't get access to it. Someone answered that. Where is the link? Which channel? When was it? The link is under these reference materials that I've got here on number 5. It's the last one. I threw in some links to NumPy docs. A lot of what came up in this first lesson was kind of basic NumPy stuff, and also I couldn't really find I don't know if there is. Someone can tell me if there is kind of any decent documentation for this Fast.ai library beyond the source code. So I just included a link to the source code here. Has anyone come across one?
No, I think they mentioned that they're still working on documentation. That's the next thing they want to improve. So that they realize that it's not strong at the moment.
Yeah. All right. So what else? What did you find interesting? What did you learn? I think one of the things that I learned was, I'm familiar with the use of data augmentation during training. So, manipulating images, either via the color channels or rotating crops, all that kind of stuff. But it never occurred to me, and I'd never heard of data augmentation at inference time, which was something that was mentioned in the notebook. So I haven't played with it yet, but it was kind of an interesting idea. I was like, oh yeah, I guess that makes sense. It was one of the things that jumped out at me as a lesson learned. Any other? Lenny says that was a new one on him as well.
One of the lessons that I sort of learned was that you could actually decide on the learning rate based on the problem that you have, as opposed to empirically just entering different numbers and seeing which one works. That cyclical learning rate paper was really interesting. I'm wondering if anybody has an implementation that you could use for your own personal projects. I know this is part of the Fast.ai library, but I'm wondering if anybody has experience with using that method for your own personal projects.
So I don't have experience using this in production because I'm just learning all the stuff in this course, but I know that at one point it might not be lesson 1, might be lesson 2 or so. They mentioned that you can actually use the Fast.ai library in production. It's basically just a PyTorch model under the hood. So once you've trained it, you can just use whatever techniques you use to deploy a PyTorch model. So I don't think you actually need to use something different. You can actually use the Fast.ai library.
Mm-hmm. Yeah, and that interview with Rachel, I think that was one of the things that she mentioned there, is that they're really starting to promote that as a general purpose tool as opposed to something that's specific for the course. But short of that, I would imagine jumping into the source code and Googling, or not Googling, but searching in the project cyclical and figuring out where that's implemented. If you wanted to re-implement it and not use the Fast.ai library for some reason, that'd be a place to start. There was a question about talk about how to set up folders path for the homework. Can you elaborate on that question? I think actually, let me try to remember how I did this. So I think you're asking about when you're creating your own data set, how do you do it? I created another data folder at the top level called Data Marvel. And then Marvel, and then I basically just replicated the data folder and put my train images and test images in there. And then I think I also replicated the lesson and just changed the path. Did anyone do anything different? Yeah, so I just changed the path here.
No, all I would really add is that you can put this in a data folder like you did, I think, in this case, because you mentioned you use a different folder, but you can just put subfolders in a data folder. It's not nothing special about the data folder.
Yeah.
Yes, I think the library by default expects to see the train folder and valid folder. So that's what you need to have. Well, you can change the defaults with the image classifier from path in this case. So you can name your folders as you like, but then you have to define those in that method. But by default, you need train and valid folders. Yeah.
There's a question here about, did anyone mess with the SZ parameter? I did not. Anyone have any thoughts on that?
Yeah, I did just want to see what would happen if I messed around with it. And the first time, whatever I did, I put it to too large of a number, ran out of memory. So I just increased it a little bit, like 264 or something. And I do recall getting slightly better, better metrics out of it after doing that.
Nice.
Yeah, I have also played with size, because this is the size of the image, indeed, as Z. And so yeah, for my images, I had only like 12 images in a training folder and like 6 images in a validation, so very small data set. So I think the size wouldn't matter that much in my case. I just use the standard 2 to 4. I think this is the kind of default size of a ResNet model. But yeah, if you put like larger, and you have a lot of images, I think that memory can be an issue. I agree.
But it should be scaled down, right? Because this ResNet is specified for 224 pixels.
That's what I was thinking, but then when we started talking about memory issues, I questioned that. But
so maybe it's loading the image and then scaling it down, so you have a problem with some memory because it's loading the image in the original size.
I'm not exactly sure, but I don't think ResNet is scaling this. I think ResNet takes wherever you give it to ResNet, but ResNet was, what I understood from Jeremy, ResNet was trained on 224 images, so it kind of should work best with this size images. That's what kind of my understanding is. But if you want, you can use larger images, and then it takes a longer time.
But what goes into the network has always have to have the same dimensions. For sure, because the layers are not dynamic, I think.
Yeah, I agree. So the size, but you can specify size like 1000, right? That's my understanding. And then your image size would be like 1000 by 1000, and that's what you train the last layers. I believe that's my understanding. I could be wrong.
No, I think what's trained in this model is really just the last logistic regression layer. And it's not connected to the images anymore. So in the first convolutional layer, you have to put in the right dimensions on the picture, and it's always the same for this ResNet 34 model. Pretty sure about that.
Well, the last layer is going to be your, it's going to have the number of classes is going to be its size.
Yes.
So is this assuming that the images, I'm sorry to be really naive, is this assuming the images are a square, or is this just sort of like the ballpark of the size of the image, or how does that work exactly?
Well, you definitely don't need square images. I certainly didn't use square images, so it will either pad or crop, probably pad. Yeah, I would have expected that it would scale the images down, and it will pad and scale the images down, basically. But I suppose this is maybe a homework for us to go into the source code and figure out what's actually happening.
Yeah, in my understanding, I think it does use square images in a model indeed. So,
yeah.
so yeah.
Yeah, so one of the things that I've seen in my experience with image-based CNN is that the aspect ratio problem's never really been addressed. So in a lot of cases, it just squishes or warps the image into a square shape before actually using it in the network. So maybe there's a check in the code somewhere that no matter what size you give, it sort of resizes it to the optimum size for the.
That would make sense to me, yeah.
All right, let's see what
Well, obviously, I mean, 224 is obviously not very high resolution. So, you know, if there's some intricate detail that you need to detect in the image, right, you'd have to use a larger size, presumably.
But I think to Kai's point, like I've been under the impression that the kind of standard, I guess if you train from the ground up, you can do whatever you want, but the standard ResNet model and across a lot of these models was 224.
I just looked up the paper from ResNet and they say a 224 by 224 crop is randomly sampled from an image or its horizontal flip.
Huh, okay.
Yeah. I just opened the paper, searched for 224, and then this popped up. So
okay, nice.
Yeah.
So sign off had a question. How does the classifier treat the noise in the image? Heard that a little calculated noise in an image can change a dog image to an unrelated image, like image of a building.
Yeah, but that's adversarial attacks, right?
Yeah, I mean, I suppose that, you know, if there's an image that's on the edge of a classification and one class is dog and one class is building, that could randomly happen based on random noise. But it does sound like a reference to adversarial attacks, which use kind of handcrafted, strategically generated noise to trick classifiers. That is, I did a podcast with Ian Goodfellow, and I forget the name of his colleague on that paper. But that's talked about there as well as some others. Do you mean?
I think they can use GAN networks to generative adversarial networks to teach them the noise they have to show the picture or the classifier to make a false prediction, right?
So there's a question from Lenny, does it pad? I thought it cropped, yeah. We just heard that it crops. For a smaller, did you see there, Kai, in the paper for smaller images? I would imagine, I mean, it's got a pad. I don't know that there's another option. I mean, I suppose it could scale, but that doesn't seem like it would. So
the image is resized with its shortest side randomly sampled in, yeah, for scale augmentation.
So it
and
scales.
24 by 24 script, yeah.
Scales, there you go.
Yeah.
You mean it scales it up?
It scales it up. If you have a image smaller than 224, it'll scale it up, and then it will randomly crop your 224 by 224.
That's interesting, because if you put the smaller, if you have large data set and you put a smaller size, it definitely works faster. The epoch goes like faster, and then you increase the size and it goes slow. So that's interesting, because if it scale it up, that wouldn't matter what sizes you put, and it makes a difference, big difference, yeah.
So the first sentence here says, our implementation for ImageNet. So maybe the implementation is a little bit different here from Fast.ai.
Well, Fast.ai is just digging down in PyTorch. But to your point, it could be an implementation issue. It could be that, it could be that what we're really measuring is the IO bandwidth, and smaller images are faster to load, and the scaling is cheaper than the loading. Particularly for these, these fine-tuning tasks where the compute is relatively small as opposed to a large train, a full train. Good questions, though.
Yeah, I think it's a good one because to my thinking, if it was scaled up to 224, it would take all the same time because that's 224 by 224.
Mm-hmm.
So I think, yeah, I'm not quite sure, but to my thinking is that the smaller size image you put might maybe not necessarily scale it up in the Fast.ai implementation, at least. Yeah, I'm not sure.
It is definitely necessary. If you have a convolutional network, you have the size of the layer is fixed, and you have to put in a 224 by 224 picture, or you have to fill up with zeros or something. I don't know, but it has to be the size because the network size is fixed.
By you mean for training the full network, or you mean by because we are using the pre-trained network in this case, we only fine tuning the last layers, like 1, 2 layers. So
yes.
Maybe it doesn't touch the layers, so it doesn't need that. And maybe for the last layers, you could have smaller images. That's my thinking. Yeah?
So to my understanding, the image is put into the network, and then before the last layer, the features are recorded and saved, and then the logistic regression is fine-tuned. And so it would cost the same when you have a smaller image. So because it has to be scaled up to go through the network.
Mm-hmm. David posted a link in the Slack from the forums, the Fast.ai forums. Maybe some interesting data here. Did you read this one, David?
Yeah, I just skimmed through it, and it basically just tells us that, yeah, this is in fact cropped to the to a square and then to the size that we defined here. But I'm actually further confused because I know that at some point, might be lesson 2 or 3, Jeremy talks about that he's training when he's setting up, excuse me, when he's setting up a new data set and an algorithm for it, he's usually using a smaller size first.
Mm-hmm.
So training will go faster and he knows whether he's on the right track, and then he retrains on a larger size. So that works somehow, but I can't explain like how or why.
Interesting.
Yeah, Sam, I have a point here.
Okay.
I'm just reading a reply given by Jeremy Howard to the same question on the FAST forum groups.
Mm-hmm.
He says, this is on November 2017.
Okay.
He says 224 by 224 is not a requirement of any model that we use. In fact, the last lesson we trained a model with multiple image sizes. This is what he says. So I think there is some confusion which needs to be cleared.
Mm-hmm. Yeah, so I'm not sure if that's answering whether your images need to be 224 or whether the model is 224, but it sounds like potentially something that's addressed in later lessons. And yeah, I think a good kind of homework may be to look at either the ResNet paper as Kai did, or the Fast.ai source code to get a sense for how it's actually using that, at least if how the size gets from Fast.ai and from our notebooks to PyTorch. Let's see.
Yeah, possible.
So noise and images, podcasts. Another question, or maybe it was the same person, Roddy, asking about the folder structure for the courses. So let me see, because so I did, so I created a data dash Marvel, basically replicated this data structure here. And then under it is Marvel. And then models, temp train is basically the same structure that's under data. And then I put my images in train and validate, train and valid. And I notice here it says data/Marvel. I forget, I did this a while ago. I forget whether I don't know how it would find it if I actually did that. Yeah, so I must have changed this.
I just, Sam, I just noticed your file names. Can you just hold the screen over there? You know, you name the files as Spiderman.16, Spiderman.17. Even initially, yeah, initially when I looked at the original lesson, you know, I was confused, but the software doesn't require it to be, you know, you can just put in any names. You don't need to put in that Spider-Man or Wolverine, whatever, you know, in the file names.
Yeah, I didn't, I just kind of grabbed a bunch of images manually from Google Images, and as I saved them, I gave them these names. I didn't play around with the naming convention, but I assumed that it would just slurp up whatever was in the directory.
Yeah, I can confirm that I just saved them as Google gave them to me, so it's
okay.
You know, since we are on this point, I think I spent a lot of time in figuring out, you know, the images and how to upload them onto my instance, which I guess was a one-time learning. Probably everyone needs to go through it. So, and the other part was setting up the Google Compute, you know, engine platform. There is always a learning curve which was involved in that. You know, when I reflect on my lessons of the last 1 week, you know, I feel like we've been dropped in this top-down approach on the peak of Mount Everest. And, you know, we've been told, okay, look, we are giving you a world-class classifier in, you know, 17 seconds and 3 lines of code. But I guess if you have to really learn, you know, we have to really go down the mountain. You know, we need to dig deep. And but I think the lessons which I learned personally were more from the overall approach of, you know, the collecting the data, setting up the notebook, you know, moving the data to the instance. And now really the hard work starts in terms of understanding the code. For example, you know, just the discussion we had on this size 224 parameter. I think all of us need to learn a lot in terms of what sizes to play around with. So these are my learnings.
Yes, I agree with that. In the I don't know if it was the wiki or something, Jeremy talks about, like, plan to go through it multiple times. Don't spend a lot of time on any particular iteration. So I kind of made sure I understood what the individual steps were doing, at least at a high level. But, you know, I think for this approach, it's definitely, you know, I guess like anything else, like what you get out of it is what you put into it. Like playing around with the size parameter, or even spending a lot of time thinking about how that relates to the model, like this discussion. I didn't do that, but that would be interesting. I do want to kind of trace that back through the code. I did start poking around through the Fast.ai source code to try to figure out, like, when we're calling these you know, some of these models, like where that's, you know, what's actually happening there. I forget where it was. But I didn't get very far with that. I was just messing around with that stuff last night. But I do, you know, I agree, there's, you know, that's probably the, you know, the beauty of the top down is that you can start kind of at this high level and then kind of poke in deeper wherever your interest takes you. But going back to, somebody mentioned, just going back to these polls real quick. So it looks like for where are you running the lessons, other, most people are doing other. I guess I forgot to put on own machine. So that may be one of the others. Behind other is gradient, a lot of gradient users. Has anyone who's using gradient run into the can't clone the machine because the same type of machine isn't available?
I'm sorry, that was core, or that was gradient you were asking, sorry.
That was about gradient, yeah. Yeah, I set up machines with both core and gradient. This that you're seeing here is core. I started playing with gradient, and then I realized that you can stop your notebook and then not be able to spin it up again later because the machine type that you need to spin it up, basically the one that you created it, isn't available anymore. And so, you know, if that's the case, you have to start over again or wait. And so I decided to just use core, which, you know, you've basically reserved this instance that you can stop and start it at will. Has anyone run into that issue? Hopefully not, but if you do it all, if you do it all in one run, then and don't go back to it, then you're fine. It shouldn't be an issue. And there are a couple of so-sos in our How'd You Make Out with Lesson 1, but most people seem to have had a okay experience with it. Have the folks who said so-so commented or asked questions here yet? Any unaddressed issues yet?
No, Sam, I put in a so-so because, as I mentioned, one really needs to get deep into learning how the algorithm is working. In my opinion, this is just giving us a superficial view of, making us all excited and talk about it to our family and friends that I wrote a classifier in 3 seconds and whatnot, 3 lines of code. But I think once we need to go deeper, that's the reason why I gave it a so-so. Otherwise, I'm still figuring out whether this approach works or the bottoms up approach will work in the long run. So that's my viewpoint.
Yeah, so for me it worked, yeah, the top down, because otherwise we would be talking like PyTorch or Python or these basic things. But although I don't understand fully what's happened in those 3 lines of code, but it gets me like excited about this and going, yeah, I can do it, and I've got that excitement to learn more. So otherwise I would be I don't know. I just my opinion, but for me it worked for sure. Yeah, I like this.
And have you been through the course before?
Well, yeah. So I'm kind of like just before we started. I started maybe like a couple of weeks before us.
Okay.
So I kind of went through all the lessons on my own, but then I concentrated on the image recognition. But before I didn't have experience with deep learning, so for me it was like, yeah, it's great, and I like this. So. But I agree. If I want to learn more, I will go deeper. But as for the first lesson and the training model on the first lesson was like, yeah, great, yeah.
Yeah, my sense from it is that, and this is one thing I should do is go kind of skim through the other lessons notebooks. I haven't done that, but my sense is that, one of the benefits of this approach is that you can kind of take what time you have and kind of run through it, and you'll learn something, and you go through the lessons and they'll kind of pull you deeper and deeper, and then you can go through the whole cycle again and kind of go deeper on your own, knowing the things that you got from all the lessons. So I wouldn't get too stressed about it, Mahesh. Do what you can, and if you find things that interest you, just kind of drill into them and see what you can learn.
Yeah, absolutely. In fact, the good thing I liked about this course was that the links which are there in the in the course material, some of them are really, really good, and they are, for example, the link which was there on how the convolutional neural networks. It's that explained visually website, the link which is there from the course. It's a brilliant link which explains you how exactly a kernel works. So that is one part. The other thing which I found a little different, which people have been asking questions. Normally in my study of machine learning or deep learning, people talk of training sets and test sets. Whereas here we are only looking at the terminology used is training and validation. So people have asked this question. So I don't think, even though the test folder is there, I don't think, because I didn't put anything in the test folder. So all the images are only being put in the training folder and the valid folder. Whereas if you look at the other, other topics and study materials in this area, people talk of training, validation, and test sets as three separate. So maybe one will need to do the machine learning course to figure out that, because that's what Jeremy says, that you need to do that course to understand the training and valid.
Yes.
Any other viewpoint?
Yeah, for sure. So the next lessons we'll talk about this. Yeah. So by default, they didn't went that far yet with testing, but they will. Yeah, he will go to that. Yeah.
Okay, thanks.
And by default, that image classifier method has got a test folder as none, so doesn't need one. But if you shift tab, you can see what arguments it takes, and you can change your test folder to your test folder, and then you will get your test data as well. Yeah, but they will go through that. Yeah.
Yeah, my impression on that was that they're, what we're actually doing is, should be in test, because we're not doing any hyperparameter tuning or anything like that that you'd use a validation set for. Does anyone agree or disagree with that?
Well, also I think sampling for deep learning is not as complicated as you would do in more machine learning statistical projects, because it's more about performance and you won't do cross-validation or stuff with deep learning, I think.
I think my impression is that you do, but when you're, like, say, for example, you could cross-validate if you're manipulating size to see if, that, or some other hyperparameter. But if you're just kind of training on some data and testing on some data, I think of that as test as opposed to validate. But I think good point, Mahesh, and sounds like we'll dig into that in the upcoming lessons. Doug says cross-validation with deep learning would require retraining the entire neural net.
I just said one more point, Sam. ImageNet is a very, very large data set consisting of millions of images. And Jeremy mentioned it mentions it in the course that you need to take, images which are of everyday objects. I spent a lot of time, because what I also want to do in parallel is that I have a 2-year-old niece, which I want her also to essentially see those images. And I want to find out at what iteration is she able to figure out, whether she's able to classify it correctly or not. That's the reason I chose boilers and I chose engineering lathes.
Okay.
Because I don't expect a 2-year-old, to know what is a boiler and a lathe, but a 2-year-old will know what is a tree, will know what is a fruit.
Right.
So once I'm able to finish that experiment, I'll post the results of that.
Okay.
So
that's
a good
funny.
point.
All right. Let's see what other questions we have in here.
Yeah, just to add to what you can do with ResNet. So I tried ResNet 34, just the basic model on pre-trained on a Kaggle dataset. That was the furniture. So you basically have pictures of different furniture like chair, table, and stuff. And I just used that, and it gave me, it's a large data set, so the training took like a couple of epochs, took like a couple of hours. But it gives you like 80-something% just with that model. I used augmentation, I think, and it puts me like in a 50% of the competitors at Kaggle. So that's quite interesting. Just using 3 lines of code, and you top 50%. Yeah.
Is anyone doing deeplearning.ai or any other course in parallel with this?
I am listening to Andrew Ng's Stanford, old lectures. So just to brush up the basics on, linear algebra, and so it's a 10-year-old course. So I'm listening to those videos in parallel too.
Okay.
So I'm doing pandas, NumPy, all this kind of stuff that is needed as well. But it's on the side of machine learning as such, but yeah, that's something I need to. So that's something I'm doing.
Okay.
Well, I watched some of the videos, and Andrew Ng is really good in explaining, so I would recommend that.
The deep learning AI one?
Yeah, I just watched some of the videos. I did not really do the course, but he's a very good explainer in my opinion.
Yeah, agreed.
Is it the same math heavy course as his machine learning at Stanford?
I think it is, but for deep learning.
Right.
That's the impression I've got from, I haven't gone through it, but that's the impression I got from people talking about it.
I think some linear algebra is helpful.
Right.
I would also suggest that people who do not know Python and NumPy should, I mean, I'm assuming most of the people over here have worked with Python and NumPy. But I think once you start reading the code, you need to actually have done programming to be able to understand, what's happening. So.
Yeah, it is deep learning for coders after all, so you have to have some of that.
Yeah.
And again, I found this NumPy cheat sheet kind of interesting, and plan to have these docs close at hand in case I come up with any questions.
So did you guys
reference?
Go on.
All right, go ahead. I was just going to ask, are those the references, links there, are they posted somewhere or?
I will drop this entire thing into the Slack.
Okay.
So I'm just curious how many of us did what Jeremy mentioned, like did we try to recreate that Jupyter notebook from scratch, or we just like shift enter? Because yeah, that's another thing. That's how much you learn depends on how much. For me, it was like 50-50. I tried to recreate some stuff, and some of that I just used what he provided.
Yeah, that's a good question. I shift entered. I mean, I did not like there's a, run all, clear and run all. I didn't do that, but I did like shift enter, try to understand what was going on in a given box, like with some parameters, and then kind of continue down. But I didn't try to type it up in, either in a separate file or in a separate notebook.
So I tried using this on a totally different data set, which is a current Kaggle competition, a humpback whale identification challenge. And I don't even know if this algorithm is useful for that challenge. But the main difference is that it's using a CSV file for the labels. And so you have to use the from CSV method for the image classifier instead of the from path. So that's one major difference. It seems to be like I used this with the dog breeds data set and it worked, but it doesn't work on the humpback whale data set, and I don't know why I'm running into a CUDA runtime error 59 device side assert triggered at and then some line. And if you Google that, it's something about a label or a data point being -1, and that breaks CUDA for some reason. And that's where I got stuck, like trying to push the envelope as much as I could, diverting from the basically the copied notebook. Yeah, that's where I stand right now, and that's the kind of problems that are not really related to learning how these things work in principle, but to actually get them to work, right? So I think that's a big part of the learning that we also have to do and are going to run into the next couple of weeks.
Mm-hmm. So you mentioned the humpback whale identification. Are there any other, I think someone mentioned another Kaggle competition? Anything in particular jump out as a good one?
Yeah, I've also
Someone
used
talked
that.
about the furniture, right?
Yeah, so I did furniture, and it worked. It worked. It was good. Also, good result. I also tried that model on the NIST data set, the digits, handwritten digits, and it also worked quite well. Yeah. The other data set I was trying was very huge data set, and it couldn't handle all of that in a memory. So also it has some memory issue. So I think then I was trying to do some do that in batches, some way like in Python. How's it called? I forgot. But yeah, that was challenging for me because the data set was so huge.
Interesting.
Just an observation I had, in the course, Jeremy mentions that one of his students was able to, do comparison of the American and the Canadian currency using just 7 images, which when I heard it, I could not believe it. So I think one of the remarkable things about this code is, with very few images, you are able to get very good classification. Like in my case, I just had 12 images in the training folder and 6 images in the validation folder of objects which I mentioned, lathes and boilers, which I'm sure were not, originally trained by the ImageNet database.
Right.
Because I think one of the newer areas of research is really to, see how deep learning can learn with very small data sets. So I think this is, in that sense, this is actually a power, this particular library is really very, very powerful.
But yeah, you have to keep in mind that you are using all the features that are trained from ImageNet. So you're really just doing a very small logistic regression on the features that are already in the network.
Okay.
Yeah, so the heavy lifting is getting the model to figure out, what's an edge, what's a circle, all these things. And that's done by training on ImageNet. And here you're just, this is more like transfer learning. You're training that last layer, that regression layer on your classes instead. So it's, you've got this model that you built on, 7+ images, and the plus is, 1.2 million, right?
Yeah.
But it's still cool. It's still cool that you can do this, and, you're not training for a day or a week or whatever to get it done.
Yeah, given what you just said, I mean, I was wondering whether overfitting is an issue. And you can do that with like Canadian versus US currency because you only have, 5 samples or whatever of each. And, you're not really at risk of overfitting. So, but that's not really a general problem, is it? It's not really a general identification problem.
Yeah, I mean, I would think overfitting is when during the training process, your model, which has, could have millions of parameters, essentially learns some of the input. Here, you're just, again, training that layer at the end that chooses which of those features are relevant. So I would think that because, if you're applying this to a totally different data set, that overfitting isn't so much an issue. Any other thoughts on that?
And we're going to learn how to unfreeze the earlier layers and retrain them in the model in the next couple of lessons.
Okay. Meaning how to train from scratch, or how to specifically untrain specific layers?
So what I learned so far is you don't train from scratch, like you don't reinitialize with random weights, but you just retrain the layers, meaning starting from the weights in ResNet, you change them a little bit so you can accommodate very different data sets better. For example, satellite images, which are way different than most of what is in ImageNet, right?
If you just randomize one layer, you would get a really big gap in the gradient, and so that's not differentiable anymore. And also, Jeremy mentioned, yes, that's because you're just fine tuning, just like you told. And Jeremy mentioned one paper from a guy called Matt Zeiler, who made some visualization what a convolutional neural network learns. And I found the YouTube video, a talk from him, which was really interesting. I watched it this morning. I will post that in the chat. So I really recommend that. That's really helpful to understand how all those filters, the layers learn to find features in images.
This guy. This is an older one, 22.
Yeah. Yes, it's a bit older. It's after this big jump in ImageNet competitions.
Mm-hmm.
It's the founder of Clarify. Maybe somebody heard of this.
Yeah, I'm showing his picture on the screen share here. He founded Clarify, and he was on the team that in the 2013 ImageNet, which is the year after AlexNet first introduced deep learning in the ImageNet competition. His team, I think AlexNet got the accuracy from 25 down to 16, and his team got it down to 12 or something like that. So Kai, if you have a link to that paper, maybe drop it in the Slack.
I have just a link for this for his talk. Very expected, but I think it's even better. So
okay, awesome, thank you.
Yeah, I'll post it in Slack.
Thank you. Lenny was asking about, was it Lenny asking about courses, about Python? And you've got a bunch of good links. I like that automate the boring stuff. And I would think, like, if you're coming from C++, I don't know that I'd do a whole Python course. I think just knowing the first 4 chapters of that automate the boring stuff, like through lists, will get you to the point where you can understand and write this level of code. There are also some Python for deep learning courses on Udemy. But if you're comfortable in C++, I don't know that I'd want to sit in front of a bunch of other videos. I don't know that that's necessary. Yeah, to Andrew's point, that won't necessarily get you to writing Pythonic code, but it'll get you through the class. How big should the training set be? Is there an upper limit? The more, the better. I think this is probably something that'll be explored in the course as well. There's definitely a law of diminishing returns. I would think both for training from scratch as well as this fine-tuning thing. I vaguely remember, I don't know if that came up in the conversation with Rachel or someplace else, but there's some, if I'm remembering the right thing, there's some approach that looks at like learning rates, and when the learning rate slows down, it stops training on new data. I forget what that's called. Early stopping, or is early stopping something else? I think that might be in the interview with Rachel.
Or explain it differently. I think I didn't understand what you mean.
The question is, how big should the training set be? Is there an upper limit, or is, the more, the better? I'm vaguely remembering a conversation with someone about, and thinking that it may have been Rachel, about how, or something I read, about how, people often train with these, large, training sets. But, it turns out, actually, I think it was, one of the speakers at the AI Summit was talking about this. Maybe Jennifer Premke, who was at Walmart Labs and is now at Figure 8, was talking about she'd have these data science teams, and they'd be training on, they'd have these 2-day training runs with, millions of images or whatever. And, when she had them do sensitivity analysis of how much training data, how their accuracy changed if they decreased the training data, they found in many cases they were dramatically overtraining, and as a result, wasting resource and time. Pretty sure that was the recent conversation I recall about that. So that definitely is a thing. And it's not always the more the better.
Andrew Inc. Likes to call it as oxygen for, data is the oxygen for deep learning. So the more data you have, in the specific case that you mentioned, maybe the images would have been maybe very similar, because I think that the quality of the data or the range of the data images that you have also would probably make a lot of difference, in my opinion.
Yeah, it clearly depends. It definitely depends on what you're trying to do and what your goals are. I agree.
Just one question I had, which is a very basic question, is that any idea whether whatever images that we are feeding, whether the network itself is also learning from our images? Whatever, for instance, I gave it boiler and late, somebody else gave it mango trees and pine trees. Is in the code, is it also learning, are the weights getting sufficiently adjusted in the main network, in the network which is getting downloaded from Fast.ai?
No,
The main
not
one,
in this case.
yeah,
No?
the main network
Okay.
doesn't change.
Okay.
It's just the decisions you're making based on the pre-existing main network change.
Okay. And any good tutorial on ResNet 34? I'm presuming ResNet 34 has 34 layers, so I couldn't find anything good on that.
Yes, I'll post it in Slack.
Okay, thanks. Thank you very much.
So back to the discussion with data. Sorry about it. So in the next lessons, Jeremy will introduce something called data augmentation. So you basically you create even more images from the images you have. It's like you transpose them like side on, or you magnify them. So you create even more images from the data you have. So, but just a heads up.
Mm-hmm. Yeah, and I'd say, take my comment about this, it is possible to have too much data with a grain of salt. It is very use case dependent. And in the case that I'm referring to, I'm not even sure that it was related to, that the underlying use case was deep learning as opposed to some traditional machine learning. I think in deep learning, it is often the case that you don't have enough images and you're doing things like augmentation. But again, it depends. I would imagine it depends on your domain and what kind of accuracy you want relative to the cost of training. All right, I think we are at the end of our time here. I think we covered everything. If you haven't already posted your homework results to the Slack, please do that. We'd love to see what everyone's working on or what everyone's done, and have fun with lesson 2.
Thank you.
Thanks, everybody.
Yeah, thank you for putting this on.
Yeah, definitely. Thank you.
All right, have a great rest of the weekend.
Yep, you too.
Bye-bye.
Thanks, bye.